leading technology partners EPLAN, Rital and Phoenix Contact have successfully combined their expertise. Together, they present the complete integration of digital data into the production process in the shape of Smart Engineering and Production 4.0. Ultimately, end-to-end virtual engineering is the key prerequisite for Industry 4.0. Using the example of a control cabinet, we have 4 stations that illustrate the end-to-end automated process, from the digital part through engineering and all the way to production. Station 5 presents partner technologies of the future. This year we are looking at digital product descriptions as a basis for preliminary certification. Let's start with Station 1, the digital part. Digital parts data is increasingly becoming the focus of attention for engineering and manufacturing. In the context of Industry 4.0, end-to-end automated processes in product development and manufacturing require a considerable amount of data to support the process. This data is generated as early as the initial design of the components. This parts data is described in the standardized E-class format and is thus available for customer-specific e-shops and digital product catalogues, as well as for engineering solutions. Which takes us to Station 2, Virtual Engineering. EPLAN makes the data available in the EPLAN data portal to allow seamless integration of the parts data in the EPLAN engineering environment. Users can select products by their properties and then drag and drop the parts into the engineering environment, or insert them directly into the electrical schematic with no additional conversion. There is a significant reduction in the need to manually create parts data for engineering and production, a process that would otherwise take up considerable time and resources and generate high costs. EPLAN interfaces to ERP and PDM systems allow process-related information such as part numbers, prices and assembly times to be automatically added to manufacturer data. This information is then available throughout the entire product lifecycle. Once they have been prepared in this way, parts data and the functional description of the control technology are used for virtual planning of the control cabinet. Gradually, a virtual 3D prototype is created in EPLAN Pro Panel. Information on machining, wiring, optimum cable routing and the necessary cable lengths is derived automatically. And step by step, a 100% digital twin emerges, all ready for validation, optimization and production. The digital twin of the control cabinet is then used to automatically generate standardized manufacturing documents, drawings and data to support and organize the production process without the need for time-consuming manual intervention. Station 3, we can see the integration of conventional automation technology in Industry 4.0 digital production processes. Using the digital product description created on the basis of Automation ML and E-class, the necessary manufacturing data is integrated directly in the machine control software, which then transforms the data into precise machining instructions. Drawings that first have to be manually converted to machine data are no longer required. Seamless provision of manufacturing data already makes it possible to integrate conventional automation technologies in Industry 4.0 digital production processes. The result is shorter throughput times, a sustained improvement in quality, and fewer errors. The digital product description also provides all the information needed for the manual processes during production of the control cabinet. Currently, considerable time and resources are still spent on wiring on the basis of a schematic. EPLAN Smart Wiring provides the production personnel with all the information needed for wiring, clearly presented in a software package. Simple diagrams and step-by-step instructions make the installation process much easier. Smart Engineering and Production 4.0 shows how software-based process support is shaping the future industrial workplace environment and how people can be integrated in the digital manufacturing process in the context of Industry 4.0. Station 4 illustrates how intelligent production will be able to operate on the basis of digital product descriptions in the future. The component is fitted with an RFID chip. The data on this chip is an automation ML format and is used by the intelligent control system to identify the manufacturing stations that are needed to machine the workpiece. This makes batch size 1 production a reality under serial production conditions. Station 5 presents Technologies of the Future. Smart Engineering and Production 4.0 shows how products can undergo preliminary certification on the basis of digital product descriptions and standards. Standards are used to verify products. These written regulations created by humans for humans are subject to interpretation. Even if operation and the underlying function can only be checked on the basis of the real product, many checks can already be carried out directly on the virtual prototype. The end-to-end digital description of all components, the standardized provision of data, and the virtual prototypes allow the manufacture of custom industrial products, geared towards a batch size of 1 and designed to meet the requirements of Industry 4.0. If industrial value-added processes are to become more efficient, we need high-quality technical product data and systematically standardized engineering and production processes. You too can benefit from the potential offered by end-to-end digitalization across different disciplines and systems and open up new business models. Join us in experiencing the world of smart engineering and production 4.0. Our work continues.